record on this computer. I'm going to turn off my video and let's look at what do I want to look at? I want to look at my Jamboard. And you should be on 313 in your books. All right, so that's the lesson we're doing today is 313. And then I believe there's a 314, and then we get into 321 and all that. There's a bunch of 3-2 sections in this chapter. All right, multiple solutions to systems of equations. How many solutions are there? Okay, we're gonna learn to find how many solutions are there to like a system of equations here. And usually when we do systems of equations, what we've done in Algebra 1 is just an x and a y. Well, we're going to ramp it up a little bit. We're going to have an x squared in one of the equations, or we're going to have a y squared in one of the equations. What does it look like for the intersection of these different types of equations? So I'm going to make this one a little bigger. Ooh, I did not know I could do that. That is great. Isn't that great? Now can you guys see it better? Okay, so we are going to get my pen in here and look at number 45 here. Let's write 3-45 on our paper. Solve each system of equations algebraically. For each one, explain what the solution or lack thereof tells you about the graph of the system. Okay, so if we write down number 45 here, 45, we'll write down, whoa, it's kind of crooked. Okay, we'll write down A. I don't have a lot of room to write here. A, let's go. Y equals -3x plus 5, and y equals -3x minus 1. Those are our two equations. And we want to, so these are both lines, right? Linear equations. We want to see where they intersect. Okay, we could use equal values method because they're both y equals. So I could set these two equal to each other, and I'll go ahead and do that. -3x plus 5 equals -3x minus 1, like so. Okay, but one thing I do notice, what do you notice about these equations? Is there something similar about these lines? Hopefully somebody noticed about these. Do you notice something about this? Something about this? What is that, guys? Why did I circle that?
Slope? I don't know.
They're parallel.
They're parallel. That's it.
Well, what's true about those two lines? What did I just draw, you guys? Somebody unmute yourselves. I'm not going to go on.
Parallel lines that have the same slope, too.
They lack a solution.
Oh, you know what? Sorry, my volume is turned way down. I couldn't hear you. Can you say that? Was that you, Jack? Can you say that again?
They lack a solution.
Okay. And I don't, did anybody say anything before that? Because I
was saying stuff the entire time, Mrs. Wakefield. You just
were you really, Mateo?
I ask anyone.
Okay, well, I have a recording, so I'll go back and listen to it. I apologize. I had my volume turned way down because I didn't want to hear all the chiming when everybody was entering because I was doing something. So yeah, Jack is right. These two have no solution, right? Because they're parallel. You know, why are they parallel? Same slope. Okay, because they have the same slope, so they're parallel. So we really know that this has no solution. We can write that. But let's say we didn't graph it and we didn't realize it. Hopefully you do when you do this problem. But let's say you didn't and you just set them equals to each other. Let's see what happens when we try to solve this algebraically. Okay, so if I like add 3x here and I add 3x here, I'm gonna get that x is going to cancel out, and so is this x, because we have a minus x and a positive 3x, and negative 3x and positive 3x. So that's going to cancel. So all we're going to have left is 5 equals -1. Okay. And if I owe you $5 and you accept -$1, then great, but 5 does not equal -1. So this, we would say, has no solution, right? This is what a no solution looks like algebraically. You get two values that are not equal to each other. Not equal to each other, that are, it says they're equal, and that's not true, right? This is not true, so we have no solution. All right, that is A. Let's go on to B here. Okay, B says, okay, we have this equation and this equation. This one's a line, but this is not a line, right? What kind of equation is part B? Figure out where I'm going to write this. Let's write B. Let's write.
Is the first one exponential?
The first, yeah, it's not exponential. It's got an exponent in it, but it's not what we consider an exponential. Other guesses? Actually, I'm going to write it up here. What would the graph of this look like, guys? It's got an x squared in it.
Parabola, maybe?
Yeah, it is a parabola. It's a parabola because it's got a y and it's got an x squared. So it's just a parabola, even though it's got a fraction. Don't let that fraction throw you off. It's just a is a fraction. It's going to be a parabola, and this is going to be a line. How many times is a line going to intersect a parabola?
Twice.
Twice.
For sure, always has to be twice?
No, not always.
No, or it could be what?
It could be like
0 times or once.
It could be once, right? Like it could intersect right at the vertex right here, or it could be 0. The line could be like underneath the parabola. So we could have 0 solutions, 1 solutions, or 2 solutions, right? So this system could have one of those. So we have to do the algebra to find out how many solutions it has. So since this is y equals and that is y equals, we should write both of them down. Here, I'll write both of them down. Let's write them down. Y equals 1/2 x squared plus 1. The other one is y equals 2x plus 1. That's going to be your line. That's your parabola. Since they're both y equals, we can use the equal values method, right, to solve this. Equal values. Since they're both equal to y. So I'm going to set the first equation, 1/2 x squared plus 1, equal to the second equation. So that part equal to that part. 2x plus 1, and let's solve this. Now we just have x's. We've eliminated the y's because we used the equal values method. I need to, I want to erase some of this, so I got to get my eraser tool, and I want to erase this part so I have room to work. Get my drawing tool back. Okay. So, if it's an x squared, I want to get everything to the other side. So let's minus 2x. If somebody can unmute, could mute themselves. I think somebody unmuted yourself and it's giving me feedback. Thank you.
That's what I was supposed to say. What knowledge just said.
Is the 1 on the 2x supposed to be negative? So right here, it's positive, right? This is a positive 2x. And then I'm subtracting 2x to the other side. So that's why it's negative, to get rid of this right here. So
what about the 1 though? Because it says 2x minus 1, and then you wrote 2x plus 1.
oh, so this one is supposed to be negative. Okay, that's what you were saying. Yes, you're right. I wrote that down wrong. So thank you. So that's a minus, which would make this a plus. We'll change that to a plus. Okay. All right, and so we have what? 1/2 x squared minus 2x, and then 1 plus 1 is plus 2 equals 0. Okay, we need to solve this. Factoring would be nice. Is there a way to get rid of this 1/2? Well, what could we do this equation to get rid of the 1/2? Because we don't like fractions in front of the x squared. So what could we do? Could we multiply it by 2 maybe? Multiply like the whole thing by 2 multiply this side by 2, which 0 times 2 would just be 0. But if I multiply this times 2, 2 times 1x squared, that'll just be x squared. And then 2 times negative 2x would be negative 4x. And then 2 times positive 2 would be plus 4, like that. Okay, now we could factor, right? Fraction's gone, so now we could factor. So factor x squared is x times x. The 4 is going to be 2 and 2. 2 times 2. 2 times 2 gives us 4, and we need a negative 2 plus a negative 2 to make negative 4x. So that's how we factor it, right? X minus 2 times x minus 2, that's the same thing as x minus 2 squared equals 0. Does anybody remember what we call that when we get the identical thing, identical factors like this? This is called the double root, right? Because you end up getting the same thing. If I were to solve this, I would get x equals 2, x equals 2. It would be double, right? I don't need 2 of the same answer. So there's really just one answer. But since it's a double root, what situation does that mean here? Do we have 2, 1, or 0 answers? We have 1. It means it's at the vertex, right? So our answer is right here at the vertex. So this is 2 something, 2 comma something. To find what the something is, we'd have to plug it into into either of the y equals equations. But that's where these two things intersect. So here's the parabola, here's the line, and they intersect at 2 something, okay? So yeah, our answer is x equals 2 for this problem. And it's a double root, so we only had one solution. That's where these two intersect. So that's where we're trying to find the intersection of two functions and not necessarily just linear. Okay, so let's move on to C here.
Wait. Let me take a picture.
Yeah, okay.
I'm good, thank you.
Are you good? I thought about getting up to get some water, but I'll do it later. All right, so I'm going to erase just this part right here for now. Make some room right here. Maybe I'll erase some stuff later. Okay, so C, let's write C. C is y squared equals x, which, what is that? And y equals x minus 2. Isn't this a sideways parabola? If you're not sure, you can look at your parent graph toolkit.
I think it's a sleeping.
Yeah, it's called the
Parabola.
sleeping parabola, right? Sideways sleeping parabola. So that's a sleeping parabola. And what is this guy right here? So
Just linear, like our
linear.
normal.
So how many times is that going to intersect for these two? Same as the last.
Can it be 0, 1, or 2 like we just did?
Right, same as last time, right? It could be twice, it could be once, or it could be none. All right, so let's find out what this situation is. So I'm actually going to have to erase this stuff. I should have did a clear screen, then I could have had more room over here. I don't have much space.
Wait, so if
on
it's a
this.
y squared and a x squared together in the same equation, is that a circle?
Yeah, that's a circle if it's x and y squared together. That's right. Because you're curving the x and you're curving the y, so you're making a big curve, which is a circle. Okay, so how do we, the easiest way to do this, I think, is to solve both of them for x. So here, did I write down? So this one is already solved for x, right? X is equal to y squared. Well, let's solve this one for x. Let's add 2 to both sides like this. Okay, if I add 2 to both sides, I get x equals y plus 2. Okay, why did I do that? Because I wanted basically to use the equal values method, right? So if x is equal to this and x is equal to that, can I use equal values now to set these two equal to each other, right? So we're going to get y squared equals y plus 2, because this was equal to x and that was equal to x. that equals x, that equals x. So they equal each other. So we set them equal to each other. Well, now this is just a quadratic equation. So let's just go ahead and subtract y and subtract 2. Subtract y and subtract 2 to get this equation equal to 0. 0 equals y squared minus y minus 2. Okay, and we should be able to factor this now. Y squared factors down to y times y, and 2 is prime. That's the easiest one to factor. That's 1 times 2. And we need a -1, so the 2 will be negative and the 1 will be positive. We set both of these equal to 0. We solve them. We get y equals -1 and y equals 2. Do we need to go back and solve? Yeah, we need to, you know what? I haven't been solving for x, have I? So now I need to go back and solve for x. So my bad, guys, I haven't been solving for x. So, you know what? Let me double check that. I'm going to double check that in the answers in my CPM book. Let's go to answers. We're on number 45, right? There are 2 intersection points. So C says 4, 2, and 1, -1. So yeah, we have to find x and y. Last time we found, for B, we found x is 2, right? So we actually have to find y, and we'll get y equals 3. So it's just for B. A, they were parallel, so we didn't need to do that. Okay, that's good to know. Back to my Jamboard. All right, so I just realized we have to solve for x too, because we're not getting intersection points. All right, so get my pen back. Where's my pen? There it is. I'm gonna change colors. Okay, so we need to solve for x. So we can use either of these equations. They're both set up for x. I don't know which one's easier. Which one do you like better, the first one or the second one? I'll just use the second one. It's a little easier. X equals y plus 2, so -1 plus 2. And so that's going to be the first solution. Our second solution is going to be +2 plus 2, right? That came from here. X equals y plus 2, so x equals, we got y. This is our first y. This is our second y. So -1 plus 2 is 1. 2 plus 2 is 4. So that's our x's. Ooh, which one goes with which? Oh, well, this one goes with this one, right? So we have to put these together. So the solution here is 1, our x is 1, and our y is -1. So that's 1 point where they intersect. For this one, we got 4 for x, and we put in 2 for that one, right? So a little tricky there. It's interesting. It's a little trickier. You have to keep your x's and your y's straight. Okay, so that's where they intersect. If we were to do this on Desmos or your graphing calculator, these are the points you would get for intersection, right? And I put a picture of the graphing calculator on here. Let's see if I could do this, make this smaller. Oh, it's moving around. I didn't want that. Let's see, control. No, what I want to do is control minus. Oops, I did control. How did that go? Control plus when I'm pressing minus. It's getting bigger. Okay, there we go. I wanted to go to the next slide to show you guys. I got the graphing calculator on here. Where is it? Oh, okay, there it is. And the y equals button, I need to clear this. Sorry, I can't see anything until I clear this. Writing. Hopefully you got it down. So the y equals button is right here, right? So you turn your calculator on, you press y equals, and then the x button is right here. So if you want to do y equals x squared, you press that y equals, and then you press x, and then you press like squared right there, and it'll graph your parabola on here. And then you press the graph button right here. Okay, so that's how easy it is to graph something on your calculator. You can look it up on YouTube too. So you want to use your calculator if you have it. Definitely practice graphing these on your calculator, okay? All right, need to go back to the screen. So sorry, I had to erase C so that we could see the calculator. On to D. D now, you know what, I'm gonna move this up because I want more room to write. So let's do that. And I need to get my pen back. All right, D. Let's see, what do we have for D? We have this, which is a line, and this, which is another line. Oh, that's easy. That is so easy. 4x minus 2y equals 10. And I'm going to write the other one right next to it. Y equals 2x minus 5. Okay, line and line. So it's either going to have one solution, or they're going to be parallel and have no solution, or they could be the same line. If they're the same line, they have infinitely many solutions, right? Remember that from Math 1 and maybe Math 2? To solve these, I think substitution is the easiest way to solve these, okay? Because this is y equals, it's set y equals. So in place of y, I'm going to put, or you know what? Actually, I'm going to solve this for y and see what I get. Let's say I notice that there's a factor of 2 in here, right? Like 2 goes into 4, 2 goes into 2, 2 goes into 10. So let's just divide everything by 2. So this is one way to do it. Right, exactly. In order to see that they're the same, I need to divide by 2, right? So 2 goes into 4 2 times, 2 goes into 2 1 time. So what we have is 2x minus y equals 5. Okay, now if I solve this for y, if I, let me add the y over here and add the y. Why did I do that? To make it positive, because I want a positive y. And so I get 2x equals y plus 5. And then I'm going to subtract the 5 to the other side over here. My bar is always in my way. I have to move it around. You guys can't see my bar, but I have a toolbar. 2x minus 5 equals y. So you actually see this equation and that equation end up being the same, right? So we have this situation right here. If the two lines are the same line, first line, second line, where are they going to intersect? Everywhere on the line is an intersection point. So we have infinitely many solutions. So go ahead and write, that's what this is. Infinitely many solutions for this, because they are, the two lines are the same, right? The two lines are the same line. Okay, so therefore, there are infinitely many solutions. I'll teach you a cool trick from higher level math. I don't know why we do this, and this is like so cool. You're like so smart if you know this. This is the sign for therefore in math. I don't know why in like traditional higher level, like college math, therefore, the two lines are the same. Therefore, there are infinitely many solutions. So that just means therefore in higher level college math. I don't know, that just came back to my brain. All right, so that is part D. You guys got that? Good. Can I erase it? I'm gonna get a quick drink of water. I'll be right back while you finish copying that down. All right, I'm back, guys. Sorry, I was really thirsty. It's good to take a stretch break too. You can stand up and stretch. All right, now I'm going to erase this, okay? Clear all drawings and go to the next slide. So the next problem, the last problem we're doing today is 46. Now consider this system. So let's ramp it up big time. Let's go ahead and square the x's and square the y's. And I don't know if this is why you asked that question earlier, Mateo, like what if you square the x and you square the y, what does that make?
Circle.
It's a circle, yes. So this is a circulo. I don't know if I said that right. I probably butchered that. Sorry, guys. This is a circle. Okay, so if we have a circle, and then what is this, you guys?
Parabola.
That's a parabola. How many different ways can a circle and a parabola intersect? How many intersections will there be? If I draw it like this, how many are there?
2.
2, right? 2, but can there be more than 2?
It
Yes.
could be like 4.
Could be like 4. Like this is 4 intersections. 1, 2, 3, 4. So you could have 4 solutions. Whoa. You could have, can we have between, can we make 3? Can we make between 2 and 4? One, 2, 3, right? So we could have 3 solutions. Can we have 1 solution?
Yeah, with the vertex on the top.
The vertex on the top, right? Or it could be like slightly tangent to it, like just barely touching it right there. Okay, so just 1 point. So we have 1 solution. Or we could have, maybe they don't touch at all, right? Or no solutions. Okay, we're gonna have one of these. And how many solutions do you expect the system? Explain how you made your prediction. So predict, what do you guys think? Make a prediction for A, so 346A. I think there's gonna be, there will be how many solutions? And you put a number. Okay. B, solve this system by graphing. How many solutions do you see? Was your prediction in part A correct? So what we need to do is I need to erase this, okay? Is it okay if I erase this? Maybe I don't need to. Yeah, I do need to. Okay, why do I need to erase this? Because I need to go to Desmos, and I had Desmos open, but I accidentally closed it. So let's go to desmos.com. To solve it by graphing, we need to use Desmos, especially for the circle. That one's harder to graph on your graphing calculator, but Desmos, we could just type it in. So what do we have? X squared. Oh, you know what? It's in our book. I forgot. That's why I didn't. If you go to your book, there's an E tool for this, for number 45. It is on actually 47. So if you click on 47, the E tool, I remember I did this last night. There it is. There's the graph. Okay, there's the circle. It's x squared plus y squared equals 25. And then here's the parabola, x squared minus 13. So how many intersections do we have, guys? We have 4, right? Go ahead and sketch that graph, right? On your homework. It doesn't have to be spectacular, just like, you know, do a circle in the middle and then the parabola going down like that. It happens to be at 0, negative 13 is the vertex. Go ahead and sketch that really quickly before I go back to my other Jamboard. Are we good? Can I go back? All right, I'm going back. You know, you could click on your book to get that image. And oh, you know what? We need to, I forgot, I need to find the solutions actually. So I need to go click on that. Negative 4, 3 is one solution. Negative 3, negative 4 is another solution. 3, negative 4, and 4, 3. Those are our 4 solutions, right? They all have 3s and 4s in them. So that's what you want to write down too. So I'll give you a second to write those down. Negative 4, 3, negative 3, negative 4, 3, negative 4, and 4, 3. I write these down. I noticed on some of your homework on, I think it was number 38 or 44, one of the two, I think it was 38. Some of you put that you couldn't solve the problem because you don't know how to solve for X. And I said that in the what's it called, but you can solve it graphically. So if you can't solve it algebraically and it's a homework assignment, right? Not a test assignment, you want to solve, you can solve it using graphs. So, you know, don't just write, you can't solve it because we don't know how to solve for X, but you can solve it using the Desmos, okay? That was for number 38 on your homework, because I did look at your homework last night when I was grading it. Okay, so bum, bum, bum. So those are our solutions. So now I need to go back to the Jamboard. Let's see. How many solutions we expected? I don't know. I expected either 4, 3, 2, or 1. We solved it by graphing. Now combine these equations to create a new equation so that there's only an x in the equation. There's no y. Then combine the equations in a different way so that there's only a y and not an x. Okay, which of these equations would be easier to solve and why? Okay, so how can we, oops, wow, it just went away. What happened? Okay, there, I was trying to scroll down. Nope, I want to scroll up. Just trying to see this part. I'm trying to see both of the equations and it won't let me see both of the equations. There we go. Okay, now pen. So, how can we use equal values? Can we substitute? What can we do to like combine these two equations, right? Well, there's two ways. There's an x squared in both of the equations and there's a y squared in both equations. So we can get both of them equal to x squared, or we can get both of them equal to y squared, and we could substitute one equation into the other, okay? So, oh, this one doesn't have a y squared, so you don't want to do it that way, but I could substitute this into that one. So I'll go ahead and start with that one. So since y is equal to x squared minus 13, let's substitute that in for the y right here, okay? So we have x squared, this is part C, x squared plus the y squared, right? We have plus y squared, but instead of y, I'm substituting x squared minus 13 in there because that's what y is from the other equation, equals 25. Okay, so this is only x's. Now we only have x's in the equation, and we could solve this. We could square this, right? We'd have to do we'd have to get a trinomial, so it's a little gnarly in that sense, just a little bit. So let's get rid of the x's and see what the y's look like if I just get rid of the x's. So one way that I saw to do this is that since they both have an x squared, right? I could solve this equation for x squared. Let's see, if I solve this, I'm going to write it down here. X squared plus y squared equals 25. And actually, this one's easier to solve. So I'm going to write the second equation, y equals x squared minus 13. If I want to solve this for x squared, that's really easy. I just add the 13 to the other side, add 13. So I get x squared is equal to y plus 13. Oops, y plus 13. So I can replace this x squared with y plus 13, right? That's what x squared is equal to in the other equation. Y plus 13 plus y squared equals 25. Okay, which one is easier to solve? This equation with just the y's or this equation with just the x's? I would say this one's easier to solve, right? You guys there? So I would minus 25 from both sides, minus 25 from both sides. And I get, so I'm going to start with the y squared plus y. And then 13 minus 25 gives me 25 minus 13 is 12. So negative 12 equals 0. Okay, so now we can just factor. And we get y times y for our y squared, and 12 is going to be 3 times 4. And so it's going to be minus 4, I'm sorry, no, plus 4 because it's a positive 1, and minus 3. So positive 4, negative 3 make positive 1. So y equals 3, y equals negative 4, right? Now we need to get our x's so we can plug in x back into any of the equations. I think this one's a little easier. I would plug it into this one, which I need to rewrite down here. So, so I got y, so I'm going to plug in y, 3 equals x squared minus 13. So I'm going to add 13 to both sides, add 13, which is 16, equals x squared. So x is going to be the positive negative square root of 16, which is x is equal to positive negative 4. Okay, so our solution is 4. What do we plug in for y there? We plugged in 3, 4, 3, and negative 4, 3. Right, because we got x to be positive and negative 4, positive 4, negative 4, and 3 for both of our y values, because that's what we plugged in for y right there. We plugged in 3 to get those values. Okay, so those are 2 of the solutions that we got on the circle. The other solution is going to come from plugging in, so we plugged in 3, now we need to plug in negative 4 into this equation. So I'm going to plug in negative 4 here. Be negative 4 equals x squared minus 13. Let's go ahead and add 13. You guys with me? Somebody unmute themselves. You guys there?
Yep.
Okay.
Yeah.
All right. Thanks,
Yeah.
guys. I got worried. 13 minus 4 with your guys' cameras on. I never know. 9 equals x squared. Hey, 9's a perfect square. That's going to be nice. We're going to square root that, get a positive and negative. So positive and negative 3 is x. So we're going to have 2 solutions, positive 3 and negative 3. And then what did we plug in for y there? We plugged in negative 4. Remember, we got y equals negative 4. So this is going to be negative 4. That's going to be negative 4. So those are our 4 solutions. And that's how we did it algebraically, right? So you could see graphing it on Desmos is easier, but you're not always going to be able to use Desmos on, like, let's say, the SAT or, you know, in-class learning. Be nice to have your laptop right there. Excuse me, teacher, can I use my laptop on this test? No, sorry. Okay, so those are solutions. Okay, what did D say? If you have not already done so, solve one of the equations from part C. If solving becomes too difficult, you may want to switch to the other equations. Yeah, so we used the 2, we didn't use this one, right? We could have solved that one, but we used these 2, and we combined them. We combined them to be this, and then we factored them, and that was easier than the other route. Okay, so that is how you solve a system of 2 equations that have, they both have like x squareds in them, and this one had a y squared in it. So that's how we solve both. All right, and 47 was just like, hey, graph this. It was more of 46, so we're skipping that. So these are the notes that you need to submit, okay, into the classroom. Let me clear this away. Is it good if I clear it, guys? Anybody need to take a picture? You did that already? Okay. So you need to submit this into the classwork right here, right? You need to take a picture, PDF, submit it as a PDF right here. Your exit ticket. Oh, you know what? Let me post this because it says I scheduled it for 11. So I need to schedule it right now. Exit ticket. Schedule it for, oops, I pressed the wrong
What's
button.
the exit ticket?
Exit ticket is 3 questions that you're going to answer from previous homework just to test your knowledge. Exit ticket means you're still here. If you got you're actually listening, and it's just 3 problems that you have to do before you leave. That's it. Does that make sense? It's basically it's on a Google form. It's like a quiz, right? It's just going to count for, I think, 6 homework points. At some point, I'm going to make that test points. I might make it test points. And there's 3 problems that you have to answer before you leave. And some teachers take roll using the exit ticket, like you have to submit an exit ticket or you're not counted present. I use the Zoom attendance, but I could use the exit ticket too. So, you know, you need to submit this. Okay, I'm talking and I'm not doing this right. I have to, sorry guys, I have to concentrate and make this scheduled for right now, which is 10:50. Okay, and then hopefully that will post. It might take a couple minutes to post. So when it goes live, I don't know what time you're guys, when it goes live, it'll take a few minutes. You're going to click on it, right? I don't think you can see it yet. So it's 3 questions. It's on a Google form, right? So it's going to be a Google form. It's 3 questions. You have to show your work. right? You have to show your work and submit the work with it. Okay, the 3 questions. Okay, so it's on a Google form. It's like a little Google quiz. You do the work. You have to show your work for all 3 questions and submit it with the ticket. Okay.
Mrs. Wakefield, while you're editing stuff right now,
Yeah.
you missed the S in Wednesday.
I did. Oh my goodness. Where is the Wednesday thing?
The Wednesday assignments.
I think it's at the top.
Oh, the Wednesday assignments. Wednesday. That's right. Thank you. Rename. Thank you. I'm usually a pretty good speller, but sometimes, you know. Let's see. I want to end my recording here.